This is a Friday Shoes production. This is lesson 6-6 in our book on page 332. Our target today is I can graph reflections on a coordinate plane. Let me read to you here. It says the mirror image produced by flipping a figure over a line is called a reflection. You can kind of see the wonderful flamingo there. This line is called the line of reflection, and they're talking about this line right here. A reflection is one type of transformation. So reflections are transformations. We also have slides. Those are transformations. And we also have rotations. So a reflection is one type of transformation or mapping of a geometric figure. In mathematics, an image is the position of a figure after a transformation. Once you take the figure and you move it. The image of a point A is written as A prime. A prime is read as A prime. So A with that little quote mark is actually called A prime. We talked about that in another class. Now, let's draw a reflection. It says copy triangle JKL at the right on graph paper. Now, you can just watch me do these. In class, we'll practice this. So just watch this lesson as, in many cases, there's not many notes here to take unless you want to write down exactly what I had up there and maybe try a couple of these on paper if you have graph paper. So again, we have this triangle here. It's called JKL. And then we're going to draw the image of that figure after a reflection over the given line. And if you can see the line is right down the middle here. Here's the line that we're going to be reflecting over. So, what do we do first? Well, it says count the number of units between each vertex and the line of reflection. Vertex, that's where two of the lines meet, what you might call the points. You can see the points, J, K, and L. Those are the vertices, or the vertexes, if you want to call it that way. So we have to measure how far away they are from the line, directly from the line, 90 degrees to the line, straight to the line. And notice that the first point right here is 1 away. The point K is actually 4 away, and point L is 2 away. All right, what do we do next? It says for each vertex, plot a point the same distance away from the line on the other side. Okay, so you can see that red dot there. I'm actually going to use that. So you can kind of see it floating around. I'm here now on the J, but I have to do 1 unit on the other side of the line. So there you go. I measured it out, did it. Same with the K. It's 4 units away, so I got to go 4 units this way. All right, easy enough. And notice it's 90 degrees to the line. Let's see here. And then L is going to be 2 units, so I got 2 units this way. There you go. Of course, the last step is connect the new vertices to form the image JKL. Let me do that for you here. So we're going to actually go from here to here, here to here, and of course here to there. And there is our new, what we call the image of JKL, triangle JKL, and we would call it J prime. I'll do this in red. So we got to match up here. J prime, and then K prime, and then L prime. Don't forget that prime. So the image will have the prime symbols. All right, how about example 2 here? Reflect the figure over an axis, x-axis or the y-axis. There's some things here that we want you to see happen when we do these. It says graph triangle PQR with vertices P, which is -3, 4, Q is 4, 2, and R is -1, 1. Then graph the image of triangle PQR after reflection over the x-axis and write the coordinates of its vertices. So they want you to find those coordinates. So you can see they actually did this in the picture. The blue one is the original, and then they reflected it over the x-axis. Hopefully you can see the x-axis is located right here. Okay, it even says x-axis. So they reflected it over the x-axis. Now, what are the coordinates of those? Well, take a look here. It says the coordinates of the vertices of the image, and the image right here is this one, in green, are P prime is -3, -4, Q prime is 4, -2, and R prime is -1, -1. It says, examine the relationship between the coordinates of each figure. I'm wondering if you can see any relationship between P and P prime, Q, Q prime, and R prime. If you look at those, do they have any relation? They sure do. Let me give it to you here. Notice when we reflect over the x-axis, this is what happens. You can see the first numbers, or the x values, they stay the same. So for P, we have -3, and in P prime, we have -3. But then when we get to the y value, y coordinate, those are opposites. And this is what happens when you reflect over the x-axis. The first numbers stay the same. The second numbers actually change to their opposites. So somewhere in your notes, you might want to write that when you're reflecting over the x-axis, the y values are the ones that actually change to their opposites. That's all I wanted you to get out of that. Same down here, you probably guess what's going to happen here. It says, number 3, graph quadrilateral ABCD, which we did here in blue, with those vertices, those 4 points. Then graph the image of ABCD after reflection over the y-axis, which we did. You can see it there in the picture. And write the coordinates of its vertices. Well, we can write the coordinates. The coordinates, we already know A, B, C, and D. Now let's do the A prime, D prime, or A prime, C prime, D prime, and A, B, C, and D prime, I should say. Then you can see those are the points. Now, examine those relationships again. What happens when you reflect over the y-axis? Take a look at A, take a look at B. Are A and A prime, B and B prime, C and C prime, D and D prime? What do you notice? Well, I hope you see that the first numbers now, the x values are actually changing. And then just simply look at A. A is -4, 1, and then A prime is 4, 1. So the first number changes, the x value changes on that. That's all I wanted you to get out of that. Anytime you reflect over the y-axis, the first value, the x values change. All right, how about this? Last piece, use a reflection. How do you use a reflection? Well, you can help yourself make a symmetry of a particular picture. In this case, we're going to talk about a kite. So copy and complete the kite shown so that the completed figure has a vertical line of symmetry. The vertical line of symmetry is that line where we can cut something in half, and the left side and the right side would be the same in this case. So let's take a look. What's the first thing we're going to do? It says you can reflect the half of the kite shown over the indicated vertical line. So we're going to reflect that shape that they have there over the line, and it will create symmetry. So it says find the distance from each vertex on the figure to the line of reflection. Okay, so notice I put some points there, and you can see how far they are with the red line. Now I'm going to flip those over to the other side, and then you can see that green. That's kind of how that's going to get drawn. So now that I have those points, then I can draw those little lines that are extra in there. It says then plot the points the same distance away on the opposite side of the line.
Brooke Carney to the main office, please. Brooke Carney to the main office.
And then connect the vertices as appropriate. So there you go. That's it in a nutshell on what we're talking about with reflections. And when you get to class, we'll actually go through and practice a few of them. Of course, you can rewatch this video or reread the book, or you can look at some of the personal tutor videos. And as always, this has been a great Friday Shoes production.